1, GLUT1 will transport across what's called the blood-brain barrier to take glucose from the circulation into the nervous system. So it transports glucose across the blood-brain barrier. The other type of GLUT2, will transport glucose from cells and cells associated with the kidney into the circulation. So GLUT2 will transport glucose from intestinal cells kidney tubule cells. So GLUT2 transports glucose from intestinal cells and kidney tubule cells into the circulation. So GLUT2 transports glucose from the lumen of the intestines into the circulation, from the kidney tubule back into the circulation. Then what's called GLUT3. GLUT3 will transport glucose into our nerve cells. And then we have the most abundant of the glucose transporters, GLUT4. GLUT4 will transport glucose into most of the cells of the body. In most situations, the concentration of glucose is high outside the cell versus what? Inside the cell. So the concentration gradient for glucose transport into the cells. GLUT4 will transport glucose into most cells. And when we take a look at GLUT4 is said to be insulin dependent. Insulin is a what? Hormone that's produced and released by the what? Beta cells of the pancreas. Insulin promotes cellular uptake of glucose. So GLUT4 is insulin dependent. Insulin is a hormone produced by the beta cells of the pancreas. Insulin will be released by the pancreas when there's an increase in what? Blood glucose levels. So to an increase in blood glucose levels, the body wants to maintain blood glucose levels roughly around 80 to 120 milligrams per deciliter. When you eat a high carbohydrate meal, this causes a what? Spike in your what? Blood glucose levels. As your body breaks down and digests the carbohydrates, this causes an increase in blood glucose levels. So in response to the increase in the blood glucose levels, the beta cells release insulin. Insulin from the pancreas will promote cellular uptake of glucose. And how insulin promotes cellular uptake of glucose is it will what? Activate the GLUT4 of most cells of the body, activate the carrier protein, tell this carrier protein to what? Bind to bind to glucose, take the glucose from the interstitial fluid, bring it into the cell so the cell can use that glucose to produce what? ATP. All right. Right now. We said promote cellular uptake of glucose. So GLUT4 is insulin dependent. Insulin is a hormone that triggers cellular uptake of glucose. How it does that is when insulin binds to its receptors on the cells, it will activate what's called a second messenger system, which will ultimately activate GLUT4. You also want to point out insulin will also do what? Act on the what? Liver to promote formation with glycogen. Anybody with glycogen? It's just a what? Polymer of what? Glucose. So we'll act in the liver to perform glycogenesis. You polymer glucose. So taken in tandem, you're looking at a negative feedback mechanism. When our blood glucose levels are high, outside that normal range, the body releases what? By way of its beta cells, we promote cellular uptake of glucose. How do we do that? We do that by activating the GLUT4. GLUT4 will transport glucose from the interstitial fluid into the cells, produce ATP, and then also we promote glycogen formation. And taken in total, we will decrease blood glucose levels. Is that time? All right, we'll pause here. We'll